Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Taha Institute of Science and Engineering. This is the fourth lecture of the fundamental chemistry that covers the topics of elements and valency. A frequently question that is asked in the exams such as define element and classify the element with examples. Now we start the solution of the question from some background history of the element. In early ages, only 9 elements that were known are carbon, gold, silver, tin, mercury, lead, copper, iron and sulfur. These are the 9 elements that were known at early ages. And at that time, it was considered that elements were the substances that could not be broken down into simpler units by ordinary chemical means. Until the end of 19th century, only 63 elements had been discovered. But nowadays, 118 elements have been discovered, out of which 92 elements that are naturally occurring elements. And according to the modern definition, element is a substance made up of a same type of atoms having same number of atoms or same atomic number and cannot be decomposed into simple substances by ordinary chemical means. And each element is made up of a unique type of atom. Each element is made up of a unique type of atoms that have very specific properties. And some naturally occurrence elements, the natural occurrence of elements occur in nature in free or combined form. All the naturally occurring elements found in the world have different percentages in the Earth's crust, in the ocean and in the atmosphere, as we can see in this table. These are the 3 main systems of the environment, that is Earth's crust, ocean and the atmosphere. And in the Earth's crust, oxygen is 47 by percentage, weight percentages, and silicon is 28% and aluminium is 7.8%. And in the ocean, oxygen is 86%, hydrogen is 11% by weight percent, and the chlorine is 1.8%. And in the atmosphere, nitrogen is 78%, oxygen is 21%, and argon is 0.9%. Now the physical state of elements. There may be 3 physical states of elements: solid, liquid and gas. Majority of elements are solid, for example sodium, copper, zinc, gold. These are the examples of solid elements. And there are very few elements which occur in liquid state, that are mercury and bromine. And a few elements exist in gases, for example nitrogen, hydrogen and chlorine, etc. Now the division of elements. The division of element is made on the basis of their properties. And elements are divided into metals, non-metals and metallides. About 80% of elements are metals, and we will study metals, non-metals and metallides in the upcoming lectures in detail. And now how to represent an element symbolically. Elements are represented by symbolic, which are abbreviation for the name of the element. A symbol is taken from the name of that element. That name may be in English, Latin, Greek, or German. If it is a one letter, it will always be capital, as capital H for hydrogen, capital N for nitrogen, and capital C for carbon. And in case of two letters symbol, only first letter will be capital. For example, Ca, capital C and small a for calcium, and A, sodium, and here we have capital N and small a letter. And in the same way we have chlorine, that is represented by symbols capital C and small l. Here we have some interesting information. Major parts of living body is made up of water, that is 65% to 80%. It means 65 to 80% of water. The living body is made up of 65 to 80% of water, and 6 elements constitutes about 99% of our body mass normally, on which oxygen 65%, carbon 18%, hydrogen 10%, nitrogen 3%, calcium 1.5%, and phosphorus 1.5%. And potassium, sulfur, and magnesium and solids, these are the four elements that constitute 0.8% of our body mass. The copper, zinc, fluorine, chlorine, iron, cobalt, and manganese constitute only 0.2% of our body mass. Now the second topic of the lecture, that is valency. Valency is a unique property of an element. It is a combining capacity of an element with the other element. It depends upon the number of electrons. It depends upon the number of electrons in the outermost shell. If there is a simple covalent bond, then we will define the valency as the number of a hydrogen atom which combine with one atom of that element, or the number of bonds, or the number of atoms of hydrogen determines the valency of covalent compound. The number of bonds formed by one atom of that element. For example, in the following compounds, HCl, here we can see chlorine has one hydrogen atom, or have one bond with hydrogen. It means it has valency 1. And in the same way, H2O in water, oxygen has 2 covalent bonds with hydrogen, or in the other words, oxygen has a 2 hydrogen atom. It means it has the 2 valency. And in case of NH3 ammonia, the nitrogen has 3 numbers of hydrogen atoms, or 3 bonds with hydrogen. So it means in ammonia, nitrogen has 3 atoms, so its valency is 3. And in the case of methane, carbon has 4 number of atoms of hydrogen, or 4 bonds with hydrogen. So it means the valency of carbon is 4. And in simple ionic compounds, valency is different from the covalent bond. Here in the case of ionic compounds, valency is the number of electrons. Valency is not the number of atoms of hydrogen or bonds that was in case of covalent compounds. So here we are discussing the ionic compound. So keep in mind, valency In the valency is the number of electrons gained or lost by an atom of an element to complete its octet. Elements having less than 4 electrons in their valence shell prefer to lose the electrons to complete the octet. Elements having less than 4 electrons generally in their valence shell prefer to lose the electrons to complete the octet. For example, sodium. Sodium has 11 total number of electrons. It means it has one more electron to fill its octet. So in sodium lose 1 electrons to complete its octet and hence having the valency of 1. And in the same way magnesium has 2 more electrons, so it loses 2 electrons to complete its octet and have valency 2. And in the same way aluminum has 3 more electrons. It loses 3 electrons to complete its octet and hence having the valency of 3. And on the other hand, if elements having 5 or more electrons in their valence shell tends to gain electrons to complete their octet, for example nitrogen with 7 electrons, the outermost shell nitrogen have 5 electrons, so it needs 3 more electrons to complete its octet, so it gains 3 electrons to complete its octet. So the valency of nitrogen is 3. And in the same way oxygen has 6 electrons in the outermost shell and needs of 2 more electrons to complete its octet, so it gain 2 electrons and hence its valency is 2. And in the same way fluorine has 7 electrons in outermost shell, so 1 more electron is needed. 1 more electron is to be needed for fluorine to complete its octet, so its valency is 1. And now, what is radical? Radical is a group of atoms. Radical is a group of atoms that have some charge, variable valency. Some elements show more than one valency. It means they have variable valency. For example, in ferrous sulfate, FeSO4, the valency of iron or ferrum is 2. And in the same, and on the other hand, in ferric sulfate, Fe2SO4 thrice, the valency of iron or ferrum is 3. Generally, the Latin or Greek name for the element, for example, ferrum, is modified to end in OUS for the lower valency. For example, ferrous, that is valency 2, that is lower than 3. So it will be represented by OUS with ferrum, ferrous, and ferrum is modified to end in IC at last for higher valency, that is ferric, that is 3, that is higher than 2. And here we have some valencies of common elements and radicals. Sodium, Na. Sodium, its symbolical representation is Na, having valency 1. Potassium, symbolical representation K, and valency is 1. Silver, symbolical representation as Ag, having 1 valency, and the magnesium Mg, having 2 valency. Calcium Ca 2, barium Ba2, zinc Zn2, copper Cu. Copper has variable valency. Sometimes it has valency 1 and 2. and the mercury also having variable valency Hg, iron Fe, aluminum having 3 valency, and chromium have 3 valency, and hydrogen has 1 valency, chlorine 1, bromine 1, iodine 1, oxygen 2, sulfur 2, nitrogen 3, and phosphorus also having variable valency of 3 and 5, boron having 3 valency, arsenic 3, carbon 4. And here we can see there are some radical groups that are the group of atoms having some charge, just like ammonium, NH4 positive having valency 1, hydronium H3O positive 1, hydroxide OH negative with valency 1, cyanide Cn negative 1, bisulfate HSO4 negative 1. Here we can see the number of charges decides the valency. Here is plus 1 plus, so its valency is 1. In the case of hydronium, the plus 1, so the valency is 1. In the case of hydroxide, negative 1 negative, so its valency is 1. In case of cyanide, Cn and 1 having charge 1 negative, so 1 is the number of charge that also shows its valency. And the bisulfate HSO4 negative having valency 1, and the carbonate CO3 2 negative decides the valency, that is 2, and sulfate SO4 2 negative, so 2 negative will decide its valency. Sulfite SO3 2 negative having valency 2, thiosulfite S2O3 2 negative, and this 2 negative charge shows the valency, that is 2. Nitride N3 negative 3, so its valency is 3. Phosphate PO4 3 negative having valency 3. In the next lecture, we will discuss compounds in detail. Stay with us and keep watching our videos for more knowledge. Kindly like, share our videos, and do not forget to subscribe the channel. If you like our work, please press the bell icon button. If you have any question, please write down. May Allah bless you. Thank you.